Now this is a point of confusion while solving the problems, that is when to use Zx and when to use Zy. So to quickly revise what is Zx and Zy, the formula for bending stress is m divided by z. This z which is present in the denominator, this we can take either Zx or we can take Zy. The calculation of Zx and Zy, this we have seen in the previous lecture, so you can watch that. But for now in this lecture we will see when to use Zx and when to use Zy. So here 2 points we have to write it. So first case we will see case 1. The case 1 is when the load is acting, when load is acting on x-axis. When the load is acting on x-axis, then in this case we have to take zy. Okay, so you just remember it opposite, that if the load is acting on x-axis, if x-axis where load is acting, then we will have to take the zy. So we'll draw quickly. So this is our vertical column, vertical compressive member. This is the rectangular section, and this is the center. Now for this section, this is the x-axis and this is the y-axis. Now you have to identify whether the load is acting on x-axis or y-axis. Now let's take this example here, that the load is acting here. In the question it will be mentioned that it is present on x-axis or y-axis, that is it is present on axis bisecting the width or axis bisecting the thickness. So if you have identified the location, let's see the location is coming here, point P. So you can see the point P here, it is present on x-axis. That is when the load is present on x-axis, then in this case you will have to take the value of ZYY. So in this case what will be the sigma B? Sigma B will be equal to m divided by ZY. So we all know m is equal to P by E, and what is the formula for ZY of rectangular section? dB square by 6. So this will be dB square by 6. So this is the case 1. Now case 2 is when the load is acting on y-axis. So when load is acting on y-axis, when load is acting on y-axis, what we have to take? Take Zx. If y-axis is there, then we have to take Zx. If x-axis is there, then Zy. So same thing, we'll try to draw it here. This is the rectangular section. This is an x-axis and this is the y-axis. This is the centroid. Now let's say that the point load is acting here. So this is the location of point load. Now you can see the point load is acting where? It is acting on y-axis. So as it is acting on y-axis, take the Zx. So the calculation of sigma B in this case will be sigma B is equal to m divided by Zx. M is nothing but P into E, and the formula for Zx is BD square by 6, where B is this dimension, D is this dimension. So with this, now we have seen all the important concepts which are required for solving the problems from direct and bending stresses. Now in the next video we will be solving the numericals from this part. Okay, so once again we'll quickly revise what we have seen up to now. We have seen what is direct load, the load which is acting at the centroid, and what is eccentric load if the load is not acting at the centroid. If a direct load is present, then it will produce only direct stress. Okay, if an eccentric load is present, then it will produce both direct stress and bending stress. How to find out the direct stress? Direct stress is equal to P divided by A, that is load divided by area. Bending stress can be calculated by M divided by Z, where M is equal to force into eccentricity and Z is section modulus. We have also seen when to take Zx and when to take Zy. So first you identify the location of load. If the load is present on x-axis, then take Zy. If the load is present on y-axis, take Zx. Zx calculations have been summarized here, all the moment of inertia formulas and the Zx and Zy. Okay.